Then you have the transition elements, which are D block elements, but I hope you know that the definition of transition element is that if it has partial D subshell, that means D should have from 1 to 9 electrons. Okay. In what? In its ground state or in its most common oxidation state. If it is D1 to 9, then it will be transition state. And interesting fact is Zn, Cd, and Hg, which are inside the D block elements, but they are not transition element due to D10 configuration. But copper also has D10 configuration, and it is transition element because copper 2 plus the most common oxidation state, it is having D9 configuration. Okay? So this is the reason copper is what? It is a transition element, but Zn, Cd, Hg are not. Then you have the inner transition elements, which are F block elements. In this, we have actinoids as well as lanthanoids. Then we have the inert gas, which are the 18th group. Here we have helium, neon, argon, krypton, xenon, and radon. Fine. Now, on the basis of conductivity, we can divide it into metals, metalloid, and non-metals. Metals are conductor, metalloids are semiconductor, and non-metals are non-conductor. On the basis of the physical state, we can say that most of the elements, they are solid. Okay? So you cannot write the solid, but you can remember the liquids, that is bromine, gallium, and mercury. These are the three most important liquids. Then you have cesium, francium. These are not very important because these are what? Radioactive. Then you have gases. So you have noble gases mainly: helium, neon, argon, krypton, xenon. Then this is indium. This is fluorine, chlorine, oxygen, nitrogen, and hydrogen. See, bromine, gallium, and mercury are very important. Okay? So you have to remember this. Also, one important thing about gallium is that gallium has low melting point, okay, but very high boiling point. Fine. So please remember this point. I think there was one question asked regarding this particular fact about gallium. Gallium has very low melting point and very high boiling point. Just give me a second. So if you want to write points, then just write the liquids, bromine, gallium, and mercury. And regarding gallium, you write low melting point and very high boiling point. You just write these points. No need to write each and everything. Just write the important points here. Okay. Let us move on a bit. Now, you may be asked to get the period number, block number, or the group number of a particular element if their electronic configuration has been given or their atomic number has been given. So, for example, I have atomic number 53, and atomic number 53, it will correspond to iodine. Okay. So, if you see 53, then the electronic configuration is krypton 5s2, 4d10, and 5p5. Now, from these three things, from these three phrases, 5s2, 4d10, 5p10, 5p5, we can calculate what? The period, the block, and the group number. First of all, the period is the highest number of shell which contains 3 electrons. So if you look here, it is 5s2, 4d10, and 5p5. So what is the highest number? Highest number is 5. So 5 is what? It is in the 5th period, I can say. Also, one more thing that you should identify here is that the number of valence electron, it is what? Number of valence electron, it will be equal to 7, not 5. Even though it is 5p5, but please remember that we have 5s2 also. The 5s2 and the 5p5 both are in the 5th shell. And 5th shell is the outermost shell. That is why the number of valence electron will be what? The number of electron in the 5s2 and the number of electron in the 5p5, that will be 7. Okay. Also remember this point. Generally, if they ask you valence electron, then people they write 5 looking at the 5p5, but it will not be 5, it will be 7. You have to see that the 5s2 is also in the outermost shell. Now the period number is very easy. The maximum, the principal quantum number, or the highest number of shell which contain electron, that will be your period. Now, what is a block? Block is the highest energy subshell which contains the electron. That means the last electron, where are you putting the last electron? So we are putting the last electron in the p subshell. That means this will be in what? It will be in p block elements. Now, group number depends on the block. Like if you are in the S block, then the number of electrons in the S subshell will be the block number. The number of electrons in the S subshell. In P block, the number of electrons in the P subshell plus you have to add 12. See? So for example, here we have, give me a second. There is some mistake here. Not 12. इसको हटाइए. 12 नहीं होगा ये. This will be 10. Group number, no? Yeah. This will be 10. ठीक है. So P block, for P block elements, what you have to do? The number of electrons in the अच्छा ठीक है. Fine. If they are writing here, it is written NP electrons. ठीक है, then it is fine. 12 we will have to write. The number of NP electrons. NP means that means you have to look only at the P subshell, okay, not the S subshell. So in that case, it will be what? Number of electrons in the NP is 5 plus 12, it will be 17. Or another formula that you can remember is number of valence electron plus 10. So the number of valence electron was 7 plus 10, it will be what? 17. For D block electrons, it will be number of NS electron and the N minus 1 D electrons. And when you add them, you will get the D block. For F block, it is always in the third group. F block is always in the third group. Okay. So please write this part, period, block, and group number. Even though in recent years they have not asked the period, block, and group number generally, okay, but please still write it. Anyone still writing? Anyone still writing? No one is writing. Achha, theek hai. Now, just tell me one thing. Raise your hand if you don't know how to write the electronic configuration, or if you have difficulty in writing. I mean, you are not very comfortable in writing the electronic configuration. Sometimes you do it correctly, sometimes you do it incorrectly. Raise your hand if you have that difficulty. No one. Fine. Then that's good. And try this question then. You should be knowing the atomic number for these elements because these are till 30 only. Yeah? So all of these are in the first transition series. Okay, I'm going to give you guys like 2 minutes. I've got two answers. Only two answers. Acha, one more answer is here. Four answers we have now. Let us see. So the transition series, the first transition series, the elements that we have, that is over. Sat, Ti, Vi, Kra, Man, Te, Ko, and Ni, Ku, Zan. So these are the elements 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Apart from chromium and zinc, apart from chromium and copper, all of these elements till 29, till 28, they have their electronic configuration in the atomic number itself. So scandium is what? Scandium is going to be 4s2 3d1. Okay? So what do we have here? Chromium 2 positive. So chromium is a bit exception. It is 4s1 and 3d5. And when you are going to remove two electrons from here, it will be 4s0 and 3d. One electron will be removed. It will be 3d4. So 3d4 is, okay, fine. So A3. Oh, A3 is only in one option. So A option will be correct. Okay, you don't have to look any further. Just give me a second, please. Copy this down. I hope you are done writing this. Okay. Now let us move on to properties of elements. The different properties that we have to learn. The first is effective nuclear charge. It is important because effective nuclear charge, it affects all the other properties: atomic radius, ionization potential, electron affinity, and electronegativity. All of these four properties, these are affected by the effective nuclear charge. And then these particular properties, they are going to affect the chemical reactivity. Okay, that's why it is important to learn about the periodic properties. First of all, effective nuclear charge, then we will learn about these different properties. Now, what is effective nuclear charge? It is the actual charge that is experienced by the outermost electron. Okay? The actual charge. Now, what is actual charge? It means, so our nucleus, it has protons, right? And then the outermost electrons is there, it is negatively charged. Now, the pull experienced by the outermost electron, effective pull. Let's suppose we are talking about sodium. Sodium will be having 11 protons, but the outermost electron will not be experiencing the pull or the influence or the effect of all the 11 protons. Why? Because inside it has some other electrons which will be shielding the outermost electron. And that is why the shielding effect is more important to learn, because again, effective nuclear charge, it is affected by, or it is influenced by what? It is influenced by the shielding effect. Now, how to remember regarding shielding? So there are only two things you have to remember. You don't have to remember these things about shielding, the exact values by the Slater's rule. What you need to remember is top to bottom. If you go top to bottom in a group, the Z effective is constant. The Z effective, it does not change. And when you go from left to right in a period, then the Z effective increases. Now, why it is happening? It is happening because if you talk about the Z effective in top to bottom in a group, then the Z increases, that is the atomic number increases, the number of proton increases, and similarly, what happens? The shell also increases. Now, if you are increasing the shell number, there is two things happening when you are increasing the shell number. When you are increasing the shell number, you are increasing the distance between proton and the electron, and what you are doing, you are also getting new electrons inside the inner shells. Okay, so when you have more, I can write more inner electrons. So even though the Z effect, even though the proton number it increases hugely, but what happens? The shell also increases, and when the shell increases, the distance between the proton and the electron increases, and there are more inner electrons which are going to shield the outermost electron, and that is why top to bottom in a group, the Z effective it is constant. Now, more importantly, you have to remember that in a period from left to right, the Z effective it is increasing. Why it is increasing? Because the proton number increases, and when you are adding electrons in the same shell, the distance is still the same and there are no more inner electrons. You are not getting inner electrons more. You are adding on the same shell, on the outermost shell itself. That is why Z effective increases if you go from left to right in a period. So please write this thing down regarding the Z effective. The conclusions are more important for you guys. Okay, na? Please write this down. Top to bottom, Z effective is constant. Left to right, Z effective increases. And then this is something that you may know, you may remember from 11th standard, that the order of shielding effect is S subshell electrons, they shield most effectively, then the P subshell, then the D subshell, and then the F subshell electron. Okay. So this is in general rule, but when there are some anomalies or there are some exceptions, then we will have to look at that the exact subshell which is shielding. Okay. So in that case, SPDF will be handy. Okay, write this done. Right? Anyone still writing? Anyone still writing? Okay. Let us see atomic radius. Okay. So what is atomic radius? I hope you all know distance between the center of two nucleus of to the outermost electron. That is the atomic radius. Now there are different methods to calculate it. We have when you have a molecule or you have any element that is present in covalent form. For example, chlorine. If you take chlorine, hydrogen. So these elements are present in the form of H2, Cl2. These are what covalent compounds. Now, in order to calculate the atomic radii for covalent compound, what do? We take the bond length and divide by 2. Then you have metallic metals, for such as copper, you have iron. In that case, what do? We take the metallic radius and divide it by 2. And for the noble gases, they don't form any compound. They're individual. So helium will be on its own, neon will be on its own. But in gaseous state, there will be 2 helium atoms. Okay? There will be 2 helium atoms, and the separation between the 2 helium atoms will take that separation and then divide it by 2. So just by looking at it, you can see that the covalent radius, if you calculate covalent radius, it will be the smallest, then the metallic radius, and then the van der Waals radius. You don't need to remember the exact values that how they are differing. These are very generic, but you can remember that the van der Waals radius is the largest, then the metallic radius, and then we have the covalent radius. Now, the factors that affect the atomic radius is what it is. The Z effective. If Z effective is very high, that means the effective nuclear charge is very high, then what would happen? It would, if the effective nuclear charge is very high, it would pull the electrons very effectively. And if it is pulling the electrons very effectively, the distance between the protons that is inside the nucleus and the electrons, what it will decrease. So the distance will decrease, and that is why what will happen? The size will also decrease. So we will say that atomic radius, it is inversely proportional to the Z effective. If Z effective is high, it is pulling very effectively, and the distance is becoming very less. And then it depends on the bond strength. So for bond strength, for example, double bond, triple bond, they will be having smaller atomic radius if you take into consideration that. And if you have single bond, that will be having larger bond length है ना. So for example, if you take H2, if you take O2, and if you take N2, ठीक है. So in that case, you can see that N2 will be having a triple bond, O2 will be having a double bond, H2 will be having a single bond. So that will also affect the atomic radius. ठीक है. Now, the important thing that you have to remember is the periodic trend. What is the periodic trend? The periodic trend is if you go top to bottom, then what will happen? The atomic radius increases. Why does it increase? Because there is an increase in the shell number. The shell number increases, then obviously you have to the atomic radius will also increase. Now, what happens in the period? In the period from left to right, the Z effective increases. And what is the effect of Z effective increasing? The atomic radius is going to decrease. As we know, the atomic radius, it is inversely proportional to the Z effective. Okay. Now, there are some exceptions that you have to remember. Aluminium and gallium, they have almost similar atomic radii, and that is because of the transition contraction. Because if you look at the position of aluminium, there is no d block elements before aluminium, but as soon as you go to gallium, there are d block elements in the gallium. Before gallium, you will have d block elements. So this gallium, what happens? It is shielded by d block elements, or rather I should say d electrons. And what is happening to aluminium? It is shielded by s electrons. Now we know that the d electrons, they don't shield very effectively. They have poor shielding effect, and that is why for gallium the Z effective is also what is high. So even though you are going from top to bottom in a group, what is happening? The Z effective is high. Why? Because gallium is shielded by d electrons, and d electrons, they have poor shielding effect as compared to aluminium. Aluminium, it is shielded by the s electrons. S electrons, they have very high shielding or very effective shielding effects. Okay. Now another thing is that 4D and 5D, they will have almost 4D and 5D. That is the transition series. Hai? They will have almost similar atomic radii, and that is because of the lanthanide contraction. Again, the same thing is happening here. 5D is having the 4F electrons, and that is why the 4F electron, they are poor shielders, and hence the effective increases. And that is why 4D and 5D, they will have almost similar atomic radius. Okay. So please write these points, periodic trends and the exceptions. Anyone still writing? Anyone still writing? No one is writing. Okay. Now, in ionic radius, there is few things. I hope you guys will remember it very easily. When you have neutral atom, then if you add electrons, what will happen? The size will increase. And if you remove electron, what will happen? You're going to remove electron, then what will happen? The size will decrease. Okay. So the order of size will be the smallest will be cation, then neutral, and then anion. Okay. Now, if you have the same the element, they are in what? They are in the same series. So this is, by the way, proportionality sign. Then the ionic radius will be directly proportional to the negative charge. That higher the negative charge, higher will be the ionic radius, and inversely proportional to the positive charge. Higher the positive charge, lower will be the ionic radius. So same series, for example, sodium, magnesium, aluminium, fluorine, oxygen, and nitrogen. So aluminum has the highest charge and the smallest size. Nitrogen has the highest charge in the negative. That is why it is having the highest, largest size. Okay. Now, for different series, you can ignore it. Okay. You don't have to learn this. Just write this one. Okay. Write this and these things. Can I write next? The ionization energy. Okay. Now, what is ionization energy? The energy that is required to remove an electron from neutral isolated gaseous atom. Now, obviously, when if you are removing any electron from the atom, you will have to give energy because the electron, it is in the control of the proton that is present inside the nucleus. It is attracted by the proton. And if you want to remove the electron, you have to remove this attraction also. You have to give force which is equivalent to this particular attraction. Okay. Now, these are the formula. We will look at these formulas in the atomic structure chapter. Okay, we have to discuss the trends more over here. So, what is the trend? If you have, we'll look at the trend, but then you have successive ionization energy. That means if you have neutral atom, you remove one electron, you will get M positive. That means with one positive charge, you remove one more electron, and you remove one more electron, right? Like this. So this is known as successive ionization energy, and this is important. Okay, na? This is important. Successive ionization energy. Now, the first ionization energy will be always the smallest, then the second ionization energy, and then the third ionization energy for a particular atom. Okay. For some atoms, what will happen if I compare, for example, let us suppose you have atom A. If I compare ionization enthalpy first and atom B ionization enthalpy first, then in that case, A will be greater than B, but it is, if I compare the second ionization enthalpy of both of these elements, then you may find that the B is having second ionization enthalpy for B is quite high rather than that of A. So if you know the first ionization enthalpy of two different elements and you can compare them, it is, I mean, not inherently it will follow the same rule when you are going for the second ionization enthalpy or the third ionization enthalpy. Okay. But for a particular atom, this is always true. The first ionization enthalpy is the least, followed by the second, and followed by the third. Okay. Now the total energy that is required for the formation of any M positive is what it is: the first ionization, second plus third plus fourth until the nth. So for example, if I want to calculate the energy that is required for the formation of M4 positive, then I will have to do the ionization enthalpy 1 plus ionization enthalpy 2 plus ionization enthalpy 3 and 4. Okay? Now, these are just points. You don't have to write anything. What are the factors that affect the ionization enthalpy? By the way, this is IP. IP is short for ionization potential. It is the same thing as ionization enthalpy. Now, obviously, it is directly proportional to the Z effective. Why? Because if the proton is, the effective nuclear charge is very high, that means it will be pulling the electron, and the attraction between the nucleus and the electron will be very high. You will have to break that attraction, and for that you will have to give a higher amount of energy, and hence the ionization potential will be increasing. It is inversely proportional to size. It is also quite easy to understand, because if you have something which is very near and something which is very far, so in this case, when the distance is smaller, you will have to put in more energy to remove the electron, because the force of attraction will be greater. Now, it is directly proportional to the positive charge. Why it is directly proportional to the positive charge? Because if you have removed one electron, from the atom already, then you will have a higher Z effective. Because you have removed one electron, the shielding will be a bit lesser, and that is why you will have to put more energy. And for negative charge, you're already, the atom, it is already having a negative charge. If you remove the negative charge, then what will happen? If you remove the negative charge, then it will come towards neutral, and neutral is more stable. That is why it is inversely proportional to the negative charge. Now, the electronic configuration, the stable configuration, have higher energy required. For example, if you have half-filled subshells, for example, here you have nitrogen and oxygen. So if you look at nitrogen is having atomic number 7, that will be 1s2, 2s2, and 2p3. And 2p3 is what it is, half-filled. But if you compare that to oxygen, it is 1s2, 2s2, and 2p4. So even though oxygen is having a higher Z effective, with 8 protons, but what is happening? The ionization enthalpy of oxygen is what it is, lesser than that of nitrogen. What is the reason? The reason is 2p3, half-filled subshell. Okay. Then we have the penetration. If you are removing electron from the S subshell, it will be difficult. If you are removing from the P, it will be a bit less difficult. If you're removing from D, it will be less difficult, and it will be very easy to remove the electrons from the F subshell. Now, for example, if you look at beryllium and boron here, okay. So what is the atomic number of beryllium? Beryllium atomic number is 4 and boron is 5. So beryllium 4. 4 means you are having 1s2 and 2s2. Then you have 5, that will be 1s2, 2s2, and 2p1. Now, in this case also, boron, it is having 5 protons, that means higher Z effective, but it is still easier to remove the electrons from boron. Why? Because we are removing from the P subshell rather than from the S subshell. Okay? Now, similar thing is for the antimony and tellurium also. Antimony will be having a half-filled subshell, tellurium will be not having a half-filled subshell. Okay? It is similar to that of nitrogen and oxygen. Okay? So please write this whole thing, the factors affecting ionization potential. Please raise your hand once you're done writing. Questions are coming, by the way. Okay, let me just discuss all of these topics, then the questions will come. Anyone still writing? Fadil, Maria, Fadil, why are you late? Yes, Fadil. Fadil done. Okay. Why are you late though? You're quite late. I hope you have seen the time that the class starts at 12 noon. Okay. That is 2:30 Indian time. Anyone still writing? Tarif, Shahid, Iyad, anyone?
Yes, sir.
Nobody is writing? Tarif done?
Yes, sir.
Okay. Now, ionization potential has certain application. Oh, okay, fine, no problem, Fadil. Ionization potential, it has certain applications. For example, metallic character is the most important application. It is inversely proportional to the ionization potential. The easier it is to remove the number of it is the easier it is to remove the electrons, higher is the metallic character. Because by definition, what is a metal? Metal is an element which has a tendency to lose electron. So if it is losing electron easily, that means it will be having a lower ionization potential and the metallic character will be high. Similarly, the reactivity of metal will also depend on the same thing. That is, it is inversely proportional to the ionization potential. If a metal it can easily lose electron, that means it will very reactive, and that is why low ionization potential or low ionization enthalpy means higher reactivity. Now, the electropositive character. Electropositive means the of an element to lose electron. So it will also be higher if what the ionization potential is lower. And then the reducing nature. Okay. The reducing nature is also directly proportional to the ionization potential, inversely proportional to the ionization potential. How? Because if an atom is going to be a reducing agent, that means it will be reducing others. Reducing others. Now, how reduction happens? Reduction happens by gain of electron. That means the element or the metal which is having a higher reduction potential, or sorry, which is having a higher reducing nature, a a good reducing agent will make the other element gain electrons. How the other element will gain electron? Our element will lose electron. Okay. So if you have an element with lower ionization enthalpy, it will easily lose electron, and that electron will go to some other element, and that element will be reduced. That is why reducing nature is also inversely proportional to the ionization potential. The ionization potential should be low and the reducing nature will be higher. Now, then if you look at the ionization potential, the trend, then from left to right, the ionization potential, it increases. And it is quite obvious. Why? Because the Z effective is also increasing and the size is also decreasing, right? The size is decreasing and the Z effective is increasing. Z effective increases, that means you will have to put more energy. Size decreases, that means also you have to put more energy. Top to bottom, the ionization potential, it decreases. Why? Because the size of the shell number increases. Okay? Size increases. The shell number increases. That is why the top to bottom ionization potential is lower. Now, we can also talk about the stability of different oxidation state. Now, if you consider the successive ionization enthalpy, but these are values you don't have to remember. So chhod dijiye aap, theek hai? But if they have given you values, then you can determine the stability of different oxidation states also. The next property that we have to learn is the electron affinity or the electron gain enthalpy. What is electron gain enthalpy? Electron gain enthalpy is the energy released or absorbed when an electron is added to neutral gaseous atom. Now, generally, when we add any electron, energy is released. Energy is released. Now, in order to understand why the energy is released when you add electron, even though you are going from, it does not mean that, for example, X is neutral and X negative, it is what? X negative is having a negative charge. So it does not mean that X negative is more stable. X negative will be quite reactive. But when you talk in terms of the energy is released when you add electron. Now, why happening? Because, for example, if you have protons here and you have 11 electrons, so if you look at 11 protons and 11 electrons, then you can see that what is happening here, there is attraction between 11 protons and 11. So there are 11 attractions, I can say. But if I add one more electron here, now I will be having 12 attractions. That means the force of attraction is going to increase if I'm going to add more electron, and that is why what is happening? The energy is released as we are adding electrons. So generally, what will happen? The energy will be released. Obviously, there will be certain exceptions, huh? As it is appeared. Generally, it is what exothermic when energy is released. Now, delta HEG, it is the final state, that is anion minus the atom. Now, moving on to what are the different parts we have to understand about the electron affinity? The successive electron affinity. Successive electron affinity means that you have atom, you add one electron, that will be the first electron affinity. You add one more electron, it will be the second electron affinity. EA2 or higher, that means the first, if you compare to second, third, and fourth, the higher, it is always endothermic due to the repulsion between anion and incoming electron. This is very important. EA1, it is what? It is always, it is what? It is generally exothermic. But the second electron affinity, the second electron gain enthalpy, it is always endothermic. That means it is what? It is always going to require energy because of the repulsion between the anion is negatively charged, and the incoming electron, which is also negatively charged. Now, the factors that affect the effective, the factors that affect the electron affinity or the electron gain enthalpy is the Z effective. That means it is directly proportional to the Z effective. Higher the positive charge, higher will be the energy that is released when the incoming electron is added. And it is inversely proportional to size because it is easier to add electrons in the higher shells. Now, if you look at the trend you have to right here. If you go from top to bottom, then the then the electron gain enthalpy, it decreases. What does it mean? It becomes more and more negative. And when you go from left to right in a period, then the electron gain enthalpy, what happened? That there is an increase in the negative. Okay, so please write this down. Periodicity and the factors. It's not actually clear. I think it will be more clear that electron gain enthalpy is gets more negative from left to right in a period. Okay. And similarly, if you're going top to bottom in a and gets less negative from top to bottom in a group. Okay. So this will be more effective. I mean, you write it like this: electron enthalpy gets more negative left to right. As we go from left to right, it becomes more negative, and as we go from top to bottom, it becomes less negative, more negative and less negative. Anyone still writing? Anyone still writing? Now, the few exceptional points that you have to look for electron gain enthalpy is that the second period elements, they have lower electron gain enthalpy than the third period elements. ठीक है? Lower का मतलब क्या हुआ? It is less negative. ठीक है? Now, as you know, what should happen if you go from top to bottom? If you go from top to bottom, that means you're going from second period to the third period, then what should happen? It should get less negative. But it is actually it is the other way around. What does it mean? It means that boron and aluminum, if you compare them, then what is going to happen? Boron will be having less negative, aluminum will be having more negative. So similarly, carbon and silicon, nitrogen, phosphorus, oxygen, and sulfur, and fluorine and chlorine. Now, why it is happening? It is happening because the fluorine, the oxygen, the nitrogen, all of these are what they are having a very small size. And it was very difficult to add electron if you are having a very small size. Fluorine, it has, first of all, fluorine, it is very exceptional because 7 electrons you already have, and you are going to include one more electron. So a very high amount of repulsion will be faced by this incoming electron when it is entering the F subshell, and the repulsion will be even more because of the small size. It is the same 7 electrons in the chlorine, but chlorine is a bit bigger in size. That is why the repulsion will not be as severe as it is in the case of fluorine. Okay, so this is quite important point that you have to remember. Now, this is something that you have to remember. Okay, so the maximum electron gain enthalpy is chlorine, like around the complete periodic table, and oxygen, it has the least in its group. So this is also quite important to write. So please write this exceptional point. And this is like one of the most important exceptions. Huh? Write this down quickly. No, this is a small relationship between ionization potential and electron affinity. Okay. So if you look at the neutral metal and you're removing electron, that means it is ionization potential. And then you have the cation. Now, if you add electron to the cation, what we are talking about? We are talking about the electron gain enthalpy. Okay. Similarly, if you talk about a neutral atom and it is gaining electron, so it will be electron affinity. And if you are removing electron from a negatively charged species, it will be ionization potential. Okay. Now, in this case, the ionization potential of the metal, we are talking about metal because first of all, we are removing the electrons, and removal of electron is a characteristic of metals only. Yeah? Metals, they tend to lose electron. So the ionization potential of metal will be equal to ionization potential of the electron gain enthalpy of the cation. Similarly, in this case, the electron gain enthalpy of the neutral species will be the equal to ionization potential of the negative element. Okay, so this is small point that you can remember. This is quite logical also. And if you get this type of question directly, then you can answer it at that time also. Now, the next is electronegativity. Okay, let me tell you something very interesting about these properties. Okay, so first of all, we learned about the Z effective, and we learned about the atomic radius. Z effective and atomic radius are the most important properties which determine or which affect the other properties. And the three other properties that we learn, they are first of all ionization potential, then the electron affinity, and now we are going to learn about the electronegativity. Ionization potential tells you about the losing of electron. That means it is talking about metals. So whenever we'll talk about metals, we'll have to look at the ionization potential. Then we are talking about electron gain enthalpy, and electron gain enthalpy is the gaining of electron, and that is a characteristic of what non-metal. So whenever we'll talk about non-metal, we will have to look at the electron gain enthalpy. Then comes the electronegativity, which majorly determines the covalent nature. And this is why we are studying only these three properties. Like we can divide each and every molecule that is present in the universe as metal, non-metal, or it will be what covalent. Okay. So that this is why you have to also remember that whenever you talk about metals, you have to think about ionization potential. Whenever you're talking about non-metal, you have to think about electron gain enthalpy. And whenever you're talking about covalent character or covalent compounds, you'll have to think about electronegativity. Okay, so what is electronegativity? Electronegativity is the tendency of an atom to attract shared pair of electron. Shared pair of electron, that means electronegativity will exist only if there is a molecule, there is a bond between them. If there is no bond, individually A will not have any electronegativity. A will have its electronegativity only based on if it is attached with something else. Okay? Now it is a relative phenomena, it is a unitless phenomena, and for noble gas, we consider the electronegativity as zero. This is important, you have to also write, because noble gases that generally don't attach to anything, that is why we consider them as zero. Now electronegativity, how it is going to, what are the factors that determine it? So it is directly proportional to Z effective. Now it is the tendency to attract electrons. Now electrons will be attracted by protons, and if you have more proton, you will be having a higher effective nuclear charge. It is inversely proportional to the atomic size. If you are having electrons which are very far away, it will be difficult to attract them. It is directly proportional to the positive charge, because when you have positive charge, it is easier to attract the negatively charged electrons. If you have negative charge, it will be difficult to attract the negatively charged electrons. And the percentage S character also determines the electronegativity. Sp will have the maximum sp2 and then sp3. Now this is why, because the percentage S character is 50% and S is very near to the nucleus. So if you are having electrons in the S subshell, it will be easier to attract them. Now in the next case, sp2, you have 33% S character. That means the S character is less. Then it will be a bit difficult to attract the electrons. And then sp3, you have what, around 25%, which is even less, and that will be more difficult to attract the electron if you are in sp3. Okay, so these are the factors that is related to electronegativity. And please write these 3 points also. Anyone still writing? एक बार थोड़ा आप लोग अटेंडेंस दीजिए, तो सो तो नहीं गए आप लोग कहीं? I mean, we have not done questions. Fadil, you're present?
Yes, sir.
Fadil, Maria,
Yes, sir.
Madiha. मदिया को बहुत नींद आती, मदिया सो गई होगी पक्का. Madiha, are you there? No, see, Madiha is slept.
No, sir. I sent him message.
Achha, you're awake. Okay. Tarif, what about you? Tarif, are you there? See, देखिए तारीफ नहीं, गायब है. Shahid, Shahid is here. Okay, I can't hear, but okay. Shahid is here. Iyad, what about you? Iyad is also here. Iyad. Tarif नहीं है. Tarif, where are you? तारीफ सो गया लगता है. Next, we have the periodic trends. So in periodic trends, top to bottom, the electronic activity, it decreases. Left to right, it increases. I hope you guys would remember this one. It's not very new for you guys. These are the exception that Zn, Cd, Hg. Hg is the most electronegative, then Cd, then Zn. And similarly, you have in gallium, indium, and thallium. Okay. Now, the application of electronegativity is in terms of bond polarity. The non-polar bonds will have no difference in the electronegativity of the atoms. For example, you have H2. Both the hydrogen atoms, they will be having same electronegativity. That is why there will be no polarity. A polar bond will have, for example, HCl. So chlorine will be more polar than, it is having higher electronegativity than hydrogen. That is why this type of molecule is going to be a polar. I mean, this molecule, this bond is going to be polar. So if the difference in electronegativity is higher, the bond polarity is higher. And if the bond polarity is higher, the bond length is lower. And if the bond length is lower, the bond strength increases and the ionic character increases. Okay. So please, these are the application of electronegativity. Also at this point, the acidic nature is also directly proportional to the electronegativity, and basic nature, it is inversely proportional to electronegativity. So if the electronegativity increases, acidic character of the oxide will increase and the basic character of the oxide would decrease. Okay, and these things, I'm not doing it right now, hydrides and hydroxides also. For example, if you have NaOH, it will be basic in nature. But if you have, let us suppose, H3PO3, and you can write it how? You can write POH whole thrice. So even you see OH here, it doesn't mean that it is what? It is basic. It is still acidic in nature. Okay. And the hydroxides of base and the hydrides of hydroxides and the hydrides of metals, they are basic in nature. Hydroxides and hydrides of a non-metal, they are acidic in nature. Okay. Even if you look at H2SO4, H2SO4 is like this. So you have OH in what? H2SO4. But this hydrogen is what? Acidic hydrogen, and this OH does not breaks. What breaks is hydrogen. Okay. So, but these things will come in the main block elements. It's better to include there, not right now. Now we'll do the questions. Done, everyone? Yes or no? Please tell me.
Yes, sir.
Done. Try this question. Can you guys take 2 more minutes? Quite easy. I mean, ABCD देख लीजिएगा जरा, ठीक है? It is not the regular ABCD as you get in the board examination. थोड़ा try to put it in certain elements also, no? Like the assertion and reason, assertion thing at least. Like you are going across a period, then which will have the highest ionization enthalpy, which will have the least ionization enthalpy in those terms. Okay, I see some messages are deleted. You guys have like, okay, fine. Time is almost over. Here, guys. The first ionization enthalpy decreases across a period. I mean, this is not right now. This is the false. Sodium to fluorine. If you go like this, then sodium will have the least ionization enthalpy. Na? As you go, if you go from right to left, what happens? The Z effective increases, and if the Z effective is increasing, and the size is also decreasing. So ionization enthalpy will be what? Ionization enthalpy will also increase. So assertion is so what? False. And where do we have? And this assertion is false. A option. Okay, I don't know why many people were doing C. Make sense? Yes or no? Maria, tell me. Maria, Madiha.
Yes, sir.
ठीक है चलिए मूविंग ऑन इसमें ऐसे मतलब ऐसे थोड़ा ध्यान दे दीजिए ठीक है ना लाइक वेन एवर यू आर गोइंग टू आंसर समथिंग ना यू ट्राई टू पुट इट इन टर्म्स ऑफ लाइक एलिमेंट्स जैसे मैथ्स में आप छोटे क्लास में करते होंगे ना कि फॉर एग्जांपल एनी ऐसे अगर स्टेटमेंट दिया जाए आपको एनीथिंग विच इज डिविजिबल बाय 2 इज अ इवन नंबर तो ऐसे आप तुरंत करने लगेंगे यस ट्रू बट यू विल चेक इट ना बाय यूजिंग सम नंबर्स आल्सो you take an even number and you divide it by 2 if it is divisible or not like in a very small standard तो उसी को हम वही अप्लाई करने के लिए बोल रहे हैं like when you are reading some statement you try to apply it in different elements like across a period then you try to apply it in a period ठीक है सोडियम से हम अगर जाएंगे तो ज्यादा अच्छा होगा या फिर फ्लोरीन में कम होगा फ्लोरीन से क्लोरीन ब्रोमीन आयोडीन में क्या ऑर्डर होगा ठीक है यू ट्राई टू पुट इट इन टर्म्स ऑफ डिफरेंट एलिमेंट्स दिस let's take 2 more minutes okay Iyad Shahid and Tarif Madiha has also answered Okay. So the electronegatividity of group 14 elements from silicon to lead, it gradually decreases. Silicon to lead electronegativity, na? Silicon to lead will be what? Top to bottom. What happens to electronegativity top to bottom? If I go from chlorine, bromine, iodine, what happens to the electronegativity? It decreases or increases? Tell me, guys. What happens with the electronegativity? आप लोगों ने लिखा नहीं है क्या? I think it was here, ना? Top to bottom electronegativity, it decreases. ठीक है? So the first statement is true. And non-metal, metal as well as metallized elements. So this is also true. है ना? क्योंकि इसमें कार्बन होता है, कार्बन के नीचे जाएंगे तो सिलिकॉन जर्मेनियम दीज आर व्हाट, सॉरी सिलिकॉन जर्मेनियम तो मेटलाइड हो जाएगा, एंड देन द मेटालिक विल बी व्हाट, विल हैव लेड, इट विल बी व्हाट, लेड विल बी metallic, tin will be metallic. ठीक है, so both of these statements are true. So B is the correct option. Both statement 1 and statement 2 are true. ठीक है, are you guys not reading the ABCD options? मदिहा, तारीफ, tell me. आपने ये पढ़ा था मदिहा?
Yes, I think I got confused.
Why you are getting confused, guys? आप लोग ने तो अभी लिखा है ना, लिखा नहीं है क्या आप लोगों ने ये सारी चीजें? Whatever I told you guys to write, मतलब बिल्कुल यहीं से आ रहे हैं ना सवाल, तो बिल्कुल ट्रेंड से आ रहे हैं. I hope you have written यार, अब मतलब इस तरह से तो मत कीजिए कि लिखिए नहीं. Write this for the elements boron, carbon, nitrogen, lithium, beryllium, oxygen, fluorine, the correct order of first ionization enthalpy. You have got one answer. Mahid has answered. One more answer. Tarif. Okay. ठीक है. You try to write in terms of first of all atomic number. ठीक है, तो lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, right? So hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, and fluorine. So in general, if you see, it should be like this, that the least 3, 4, 5, 6, 7, 8, and then 9. But we have also learned that there are exceptions when we go from 4 to 5. 4 is what? It is beryllium. That is 1s2 and 2s2. We have to remove from 2s2, and in 5 we have to remove from 2p1. So it will be easier to remove from 2p1 rather from 2s2. That is why it will be 3. Then you will have 5. So lithium के बाद boron कहाँ पे? Do we have any lithium then boron? Yeah. So D option will be correct. You don't even have to look any further. ठीक है? C नहीं होगा, D होगा. This was expected. ठीक है? So there are two exceptions here. Beryllium and boron, and then you have oxygen and nitrogen also. If you look at nitrogen, nitrogen is going to have 1s2, 2s2, 2p3. This is half filled. So it will be difficult to remove from nitrogen. So nitrogen will be more than that of oxygen. Okay. So the correct order is going to be 3, then 5, then 6, then 8, then 7, and then 9. Okay. So here we have the exception 3, 5, 4. 4 maybe counted 4 and 6. Done, guys? So moving on. Try this. अब ये सारे सवाल ना आपसे होने वाले रहेंगे, ठीक है ना? You don't have to teach anything now. अब आराम से सिर्फ सवाल करते रहिए. Again, 2 minutes. Okay. Time is up. The energy required to form Mg2 plus from Mg. That means if you go from Mg to Mg2 plus, you will require some energy. Yes. This energy, that means suppose this was A, is much higher than that required to produce Mg positive. So if you go from Mg to Mg positive, this is B. So they're saying the energy required to form Mg2 plus from Mg is much higher than that. They're saying A is greater than B. Is this true Obviously, it is going to be true. Now, if you are going to remove 2 electrons, it will require higher energy. So this is true. And why it is Mg2 plus is small ion and carry more charge than Mg positive. That is also true. Right? Because Mg2 plus is what? It is small and it carries more charge than Mg positive. This is true. Now we have to read assertion because reason. Now, assertion because reason, the energy required to form Mg2 plus from Mg is much higher than that required to produce Mg positive because Mg2 plus is a small ion and carry more charge than Mg positive. And because, like, why are we requiring higher energy? Because this is having a higher charge, and that is what it is written. Carries more charge. Reason it is also true. So option number C will be correct. Both assertion and reason are correct, and reason is the correct explanation. If you have any doubts, please let me know. ए पता नहीं क्यों किया आप लोगों ने ए कैसे होगा भाई assertion is false and reason is true आप लोग statement नहीं पढ़ रहे या you read the statement and selected A or you selected A because in general in A you have both A and R are correct type of thing. Guys, what is happening? चल ठीक है ना देखिए. Correct order for electronegativity. अच्छा at least you can cross at least two parts here. ठीक है ना? ब्रोमीन का सबसे कम तो हो नहीं सकता है. ठीक है. सो एंड ब्रोमीन का फास्फोरस से कम ये भी नहीं हो सकता है. ठीक है. फ्रॉम ऑल ऑफ दीज halogens are the most electronegative element. I hope all of you guys know that. So you can at least cross these two. ठीक है. अब यहाँ पे आप बताइए एस्टाटीन. ठीक है. If you look at astatine and then you have carbon. ठीक है. So it is obvious now that carbon will be what more electronegative than astatine. Why? Because astatine is so down below the in the halogen only. It is where it is very below. बहुत नीचे. Also, one more thing is that if you look at the option number C, Acha, by the way, I will tell you now how to remember the electronegativity series. There is one electronegativity series that you can remember. You can remember it like this: phone, call, bro, इश्क प्यार है. ठीक है. This is in general you can remember. This is mostly used for organic chemistry, but still you can use here: chlorine, oxygen, nitrogen, chlorine, bromine, iodine, sulfur, carbon, phosphorus, and hydrogen. So you can see that carbon is more electronegative than phosphorus. And in the C option, carbon is least electronegative. That cannot happen. So the only option that is remaining, which is correct, is what? It is B. ठीक है. So whatever information has been given to you, आपको उसी हिसाब से करना पड़ेगा. ठीक है. फोन, कॉल, ब्रो, इश्क, प्यार है. ठीक है. You can remember it like this. I write this down. Moving on. Okay, 2 minutes. Chaliye, time is done for only one answer. Tell me about okay. Tell me about this statement. Everyone you have to tell. ठीक है? सारे लोग बताएं. Electron gain enthalpy of fluorine is more negative than that of chlorine. Tell me true or false. Electron gain enthalpy of fluorine is more negative than that of chlorine.
False.
False. है ना? This is false. ठीक है? Now we have seen that यार. I think अब इसमें आप लोगों ने अब लिखा नहीं है तो फिर हम इसमें क्या करें हैं? You will have to write ना. वही हम कह रहे थे. ठीक है? Chlorine is more negative than fluorine. Now by the way, याद which of the following statements are not correct they are asking. ठीक है ना? तो false वाले को बताना है. Ionization enthalpy decreases in a group of periodic table. Ionization enthalpy decreases in a group. That means if you are going from top to bottom, then what will happen to the ionization enthalpy? It will decrease. This is true. So option number B will be correct. है ना? Because they are asking for not correct. Decreases in a group of periodic table group. ना ठीक तो decreases it will be true. So B is present in A, B is present in C, and B is present in D. That is why the only correct option will be A, C, and D. Okay? You don't have to look any further. Make sense, everyone? Yes or no? Please tell me. Fadil, bhai, Fadil, Riha, Maria.
Yes, sir.
Yes. ठीक है. देखिए फिर से आ गया फ्लोरीन का. Fluorine has most negative electron gain enthalpy in its group. True or false? Shahid, you now do the answer, complete answer. So let's see. Fluorine has most negative electron gain enthalpy. No, false. Chlorine has the most negative. Oxygen has the least negative electron gain enthalpy in its group. This is true. ठीक है? I think this line is already there. है ना? जो हम लोग लिख रहे थे. Oxygen has least in its group. है ना? We have written that also. It is having the least negative in its group. So statement 1 is false, but statement 2 is C option is correct. Actually, moving on. Which of the following, which of the element having the highest first ionization enthalpy? That means they're asking which will be having the highest ionization enthalpy here. Okay. Very good, guys. Nitrogen is correct. Moving on. Try this. The transition metal having the highest third ionization enthalpy. See you guys. You have to look at the electronic configuration. ठीक है ना? So manganese is 25, this is 26, this is 24, and vanadium sub TV 23. So this will be 4s2 3d5. This will be 4s2 3d6. This will be 4s1 3d5, and this will be 4s2 3d3. Okay, if you remove 3 electrons, please remember you have to remove electrons from what? You have to remove electrons from the s subshell first and then the d subshell. So this will become 4s0 3d4. This will become 4s0 3d5. This will become 4s0 3d3. And this will become 4s0 3d2. Okay. Now let us compare each and everything. First of all, if you look at manganese, it was stable, half filled, and it is what? Unstable, very unstable, because it is what? D4. If you look at Fe, this was not half filled, this is fully filled. So Fe cannot be having the highest ionization enthalpy because Fe is going from partially filled to half filled. So it is going to more stable configuration. If you look at chromium, chromium is half filled here, and here if you look, it is D3. Now, I don't know whether you guys remember or not, but for D3 configuration, it is very stable because of T2G configuration. ठीक है? Because D3 में क्या होता है? It splits, and then you get what? T2G3 configuration. ठीक है? That is why this is also quite stable. Now, vanadium we cannot talk. So this is also going from half filled to, again, T2G3 also is what? It is half filled. So you cannot compare chromium. Vanadium, I mean, you cannot say anything about vanadium here. You cannot say anything about vanadium here. There is no specific configuration. So vanadium is also not true. The highest will be for manganese because it is going from stable to unstable, from half filled to partially filled. ठीक है, मूविंग ऑन। चलिए ये लास्ट देखते हैं, ठीक है, एंड देन वी विल बी डन। Okay, I've got different answers here. Both metals and non-metal exist in the P block and D block elements. क्या ख्याल है guys? जी, both metals and non-metal exist in P and D block elements. This is false now. D block elements will not have non-metals now. Or is there any non-metal? There is no non-metal in the D block elements. ठीक है? Now, statement 2, non-metals have higher ionization enthalpy and higher electronegativity than the metals. And that is true. Well, as you go from right to left, then what happens? The ionization enthalpy increases. And also what happens? The electronegativity, it is shown by chi. Electronegativity also increases. So we have metals in the S block and we have generally non-metals in the P block. So when you go from metals to non-metals, what is happening? Ionization enthalpy is increasing. Electronegativity is also increasing. So the statement 1 is false, but the statement 2 is true. C option will be correct. So Maria is correct. So that's it for today, guys. Please, I hope you have written. See, whatever we wrote now, that is why I mean complete the theory part, because most of the questions I saw was from the theory. Okay, and it's better to do theory right now, because like all the questions are from theory, but all the questions that can be asked from theory are not there. So it is not useful to do a lot of questions right now. You can do questions now once we are done with the theory, but it was very important to the theory part here. Okay. So I hope you have written these points also. Okay. And we'll meet tomorrow with redox reactions. Okay. Chaliye.